All right, so this is question number 23. The first question is asking about H0 and H1 and the hypothesis testing, whether it's one tail or two tails, right? So let's start this problem. Now, in order to define what is the hypothesis, we need to find the sentence into the problem that express the claim. And the sentence is this one. She thinks that the mean is lower. All right. So that is the claim. The claim is the mean is less, lower, all right? Means strictly less than whatever the average is here, which is 7.8. All right. So this is the claim. And because the claim does not have an equal sign in here, strictly less, so this it can be only H1. All right, so H1 is the claim. Now the negation of this for us, H0 will be the mean. Well, the negation is basically greater or equal, but for us the mean will be equal to 7.8. All right. So this is basically the hypothesis H0 and H1. Now, whether it is a one-tailed or two-tailed, it's going to be depending from the H1. All right, so H1, how do we graph it? So the way to graph it is going to be this, the bell shape. And then if this is 7.8, then the mean less than 7.8 will be a left-tailed distribution. All right, so this is a left-tailed test. So if it is a left-tailed test, so this is the area of the alpha, this is the rejection zone, and the totality of the alpha would be in here 0.05. All right, okay, so let's go and plug it in. So for H0 you're going to be the mean equals 7.8. And this is not the claim. And for H1, you're going to be the mean less, strictly less than 7.8. And this obviously going to be the claim. And to choose one tail or two tails, you're going to be two-tailed. One tail, sorry. You're going to be just one-tailed, all right? All right, let's check it. Okay, the first question is great. Now we want to figure out the critical value or values and determine to two decimal places, right? So let's go back to the whiteboard. So obviously here we said is only one-tailed, so you're going to be only one critical value. Now the issue is what kind of distribution you're going to be using. Are you using a T distribution or a Z distribution? So I hope I'm going to help you with that right now. So first of all, we noted that the sample is 32. So that's the first indication. N is greater than 30. All right, so N equals to 32 as a matter of fact. The second one, the second indication is that they are telling you here that the population standard deviation, this is the population standard deviation, is 2.6. So what does mean population standard deviation? That is nothing other than sigma. Sigma is going to be equals to 2.6. So if sigma is going to be 2.6, so sigma is known. And both of these conditions, they are satisfied. So every time you have the AND statement, all right, you definitely going to use a z-test. All right, so now knowing it is a z-test, what I'm going to do, I'm going to change my axis here. It's going to be a z-axis. I'm going to assume this is the mean equals to 0, and this is sigma. It's going to be 1. So I am looking for the z value or z critical, all right, corresponding to this area, which is 0.05. all right, so if I have 0.05 on the left side, what might be the z value here? Okay, so let's try to do it. Obviously we're going to do it on the calculator. So we have all the information, by the way. We know is a z-test, we know is alpha, the left tail is going to be 0.05, and that's all what you need, right? So we start with second vars. You're going to go to distribution menu, and you're going to go to number 3, inverse normal, because we are using z-test, and you're going to plug in 0.05 other area is always the left area, and the mean is going to stay 0 and 1, sigma is going to be 1, paste, enter, and this is going to be minus 1.6448. all right. You want to round to 2 decimal places, so you're going to be minus 1.64, I guess, right? So let's see. So here z is going to be minus 1.64. It could be as well minus 1.65 because this is what the table gives you. So it can be either minus 164 or minus 165. So let's plug in minus 164 first and see. Minus 1.64, and you're going to be only one critical value, right? Yeah, it went through. Great. Okay, so now we want to compute the z-test value. All right. So what is the z-test value? Knowing that we have z-test, so the z-test value is going to be z equals always x bar minus the mean divided by sigma divided by radical n. All right. You can use the parentheses whenever you do the application. So what is the x bar? X bar here is going to be equals to 6.8. The n we are already having 32, and sigma is going to be 2.8. So let me change the n to small. All right, so this is n here. All right, so plugging in the values, you're going to be 6.8 minus the mean, which is 7.8, divide everything by 2.6 divided by radical 32. All right, so please, whenever you do this, use the parentheses on the calculator. So parentheses 6.8 minus 7.8, close the parentheses, divided by, open the parentheses, 2.6 divided by square root, second and squares here, square root of 32. And that's basically, you get exit this one and close the parentheses and enter. So this is minus 2.175. I think you want to round it to 2 decimal places, so this is going to be minus 2.18. All right, let's plug it in. Minus 2.18. Check it. Okay, that's good. Make a decision right now. So decision is made according to the comparison about this. So we're gonna plug in the z-test. This was our z-test here. So this is equal to z-test. Now, what the meaning of z-critical? The meaning of z-critical that the threshold where you're gonna separate between the accept and reject. Always, whenever you are taking the side of the alpha is the rejection zone. So here is reject 80. All right. The other side is going to be the acceptance zone. So over here, accept 80. So we are talking about the z values here. This is the acceptance zone, and this will be the rejection zone over here. So if I place minus 2.18, the location of minus 2.8 will be right here somewhere. So definitely after this value, which is minus 1.64, right? So this is my z-test. And as you know, the z-test, as you see it here, the value of the z-test is which is minus 2.18. So the value of the z-test, which is this one, is on the rejection zone. So your decision here, you're going to be reject 80. Okay, so let's plug it in. So your decision is to reject the null hypothesis. Check it. Great. And if we rejected the null hypothesis, it can ask you there is or there is not enough evidence to support the claim, or what is my claim? My claim, going back, the claim is H1, and we rejected H0. So we say this one is bad. All right, so H0 is bad. So we are, if H0 is bad, then H1 will be good, right? So one of them is bad, one of them is good. So we are in support of the claim. So yes, we did support the claim here. All right. And did we have enough evidence? Of course we had enough evidence. Actually 6.8 is the evidence that it's gonna fall in the rejection zone. So the answer is yes, there is enough evidence to support the claim, which is H1. All right, and that's all.